The aviation industry relies heavily on various types of fuels to power its vast array of aircraft, ranging from commercial airliners to smaller, private propeller planes. The primary fuels used in aviation are kerosene-based jet fuels, such as Jet A and Jet A1 for turbine engines, and leaded Avgas for piston engines in smaller planes. However, with the increasing focus on environmental sustainability and reducing emissions, the industry is shifting towards the use of sustainable aviation fuels and exploring alternative fuels like biokerosene and hydrogen. Turbine engines, which power the majority of commercial airliners, utilize kerosene-based jet fuels due to their high energy density, safety, and cold weather performance. The two most common types of jet fuels are Jet A and Jet A1. 1. Jet A aviation fuel. This is the standard jet fuel used in the United States. It has a higher freezing point of 40 degrees Celsius compared to Jet A1, making it suitable for the generally milder climate in the US. Jet A is similar to Jet A1 in most respects, but lacks the anti-static additives found in Jet A1. 2. Jet A1. This fuel is the most widely used internationally, preferred for its lower freezing point of 47 degrees Celsius, which makes it ideal for long-haul flights and operations in cold climates. Jet A1 also contains anti-static additives, which help in preventing the buildup of static electricity during fuel flow, thereby reducing the risk of ignition. 3. Jet B, a less commonly used fuel. Jet B is a blend of naphtha and kerosene, designed for use in extremely cold weather conditions. It offers excellent low-temperature performance but has a lower flash point than Jet A and Jet A1, which can pose safety risks. Its use is generally limited to areas where its unique properties are beneficial, such as in very cold climates. Piston engines, found in smaller propeller planes, use a different type of fuel known as Avgas. Avgas is a high-octane fuel, with the most common variant being 100 LL, low lead. It is used in older, smaller propeller aircraft. However, the use of leaded Avgas has raised health concerns due to the toxic effects of lead emissions. Unleaded Avgas, G100UL. In response to the health and environmental issues associated with leaded Avgas, the aviation industry has been working on developing and approving unleaded alternatives. G100UL is a lead-free version that matches the performance of 100 LL Avgas, offering a safer, more environmentally friendly option for piston engine aircraft. Emerging and alternative fuels. The aviation sector is under pressure to reduce its carbon footprint, leading to a significant interest in emerging and alternative fuels that can offer substantial cuts in emissions. 1. Sustainable Aviation Fuel, SAF. SAF is made from renewable resources such as biomass, used cooking oil, or through synthetic processes. It can be blended with conventional jet fuels and offers a significant reduction in carbon emissions. The use of SAF is seen as a critical step towards more sustainable aviation practices, with many airlines and airports already incorporating it into their operations. 2. Biokerosene. This is a blend of biofuel and conventional kerosene, providing another pathway to reducing the environmental impact of aviation. Biokerosene can be used in existing jet engines without modification, making it a practical alternative for reducing emissions. 3. Hydrogen. Hydrogen fuel is being explored as a future possibility for aviation, offering the potential for zero carbon emissions. However, its use is still in the experimental stages due to significant challenges related to storage, infrastructure, and the modification of engines to burn hydrogen efficiently. The aviation industry is transitioning towards more sustainable practices, driven by the need to reduce emissions and mitigate its impact on the environment. While traditional fuels like Jet A, Jet A1, and Avgas continue to be widely used, the development and adoption of sustainable aviation fuels, biokerosene, and potentially hydrogen mark significant steps towards a greener future for air travel. As technology continues to evolve and the infrastructure for alternative fuels expands, the industry is poised to make substantial reductions in its carbon footprint, ensuring a more sustainable aviation sector for generations to come. Underwing refueling nozzles with quick connect couplings and bonding cables enable safe, dripless fuel transfer to aircraft. SAF-branded Bowser systems provide controlled delivery and on-site blending capability for sustainable aviation fuels. Cryogenic hydrogen storage systems require specialized venting and insulation to manage boil-off and ensure safe integration with aircraft systems. Why do airlines prefer Jet A1 to other types of aviation jet fuels? Here are some of the several reasons. 1. Standardization. Jet A1 is the most widely used and standardized jet fuel globally, making it readily available at most airports. This standardization ensures that airlines can rely on a consistent fuel quality, regardless of the location. 2. Freeze point. Jet A1 has a lower freeze point of -47 degrees centigrade compared to other jet fuels, which reduces the risk of fuel freezing in cold temperatures. This is particularly important for long-haul flights that may operate in extreme cold conditions. 3. Flashpoint. Jet A1 has a high flash point of 38 degrees centigrade, which reduces the risk of ignition and makes it a safer fuel to handle. 4. Energy density. Jet A1 has a high energy density, which means that it contains a large amount of energy per unit of mass. This allows aircraft to carry less fuel while maintaining the same range, resulting in cost savings and reduced emissions. 5. Compatibility. Jet A1 is compatible with most commercial aircraft engines, which reduces the need for specialized fuel handling and storage systems. 6. Supply chain. The global supply chain for Jet A1 is well established, ensuring that airlines can source fuel from a variety of suppliers, which helps to maintain a stable fuel price and reduce logistical challenges. 7. Regulatory compliance. Jet A1 meets the strict regulatory requirements of the aviation industry, including those set by the International Air Transport Association, IATA, the Federal Aviation Administration, FAA, and the European Aviation Safety Agency, EASA. 8. Performance. Jet A1 provides consistent performance across a range of operating conditions, which is critical for ensuring safe and efficient flight operations. 9. Storage and handling. Jet A1 has a relatively low volatility, which makes it easier to store and handle, reducing the risk of accidents and environmental contamination. 10. Economic benefits. The widespread use of Jet A1 creates economies of scale, which can lead to lower fuel costs for airlines and reduced prices for passengers. Overall, the combination of these factors makes Jet A1 the preferred choice for airlines, as it provides a reliable, efficient, and cost-effective solution for their fuel needs.